Our next presenter is Brian Pulaski. He works with Rovisys. He's been involved in a real-time project implementation. He's been with Rovisys for 22 years, and he's one of the data center verticals market managers. And he'll be talking about that project.
All right, so every product user conference always has or tries to get a few presentations of first-time users, and this is one of them. So this is our first exposure with ETAP. As far as Rovisys, actually this month is our 27-year anniversary. I actually started in April 2, so this is my 22nd year anniversary at Rovisys. We have over 500 employees there. We're located mostly in the U.S. We have an office in Singapore, and we do supply integration services around the world. We're in all the major verticals, so power and energy, oil and gas, pharmaceutical, pulp and paper, metals and mining. So we provide integration services across all the major ones. And over the last 10 years, we've had a focus, of course, in the data center vertical, which is why I'm here. So our agenda, I'm going to go over Data Center 101, what we do in a data center, how we do power monitoring inside the data center, overview of the project that we did together with ETAP, how we used ETAP there, then do some lessons learned, and then our path forward of what we're looking ahead. Okay, so here's your data center down here, the whole building, but we start off with the EPMS, which is your electrical power monitoring system. And that's what this whole presentation's about, so I won't spend too much time on that one right now. And then you have your mechanical building management system. So that's handling the environment inside that building, chilled water systems, turning the crack units on, controlling your dampers. All of that stuff is done inside the BMS system. We then have facility systems. So these are usually independent systems such as your fire alarm system, security systems, weather stations, and some other environmental information inside your facility. And then the last part of a data center is what's called a DCIM, or a Data Center Infrastructure Manager. And that handles, if you look at it, it's all the assets. So it's an asset manager looking at your racks inside your data center and all the components that you mount in there. So your servers, your hard drive space, your switches, your patch panels, all of that's, anything that you put in there is all put inside a DCIM, and then also the interconnection. So all the cabling of the fiber, all the patch cabling, everything. So you can look from one server from a port, where's this port going, and it'll show you exactly where it's stringing throughout the whole data center, including the wireways and everything are underground, under the floor. So it does a visual representation of that. We also bring in the power systems, so we know exactly what server is plugged into what outlet. So you can look at a power strip inside of a rack and know exactly where that server is plugged into. You'll know what power distribution unit is supplying power to it. So if we lose power there, what servers am I going to lose because it's not doesn't have redundant power inside that rack? All that information's all stored in there, but it gets information from your EPMS. So once you have these systems in place, you can collect this data, and they all talk different protocols up to a server, which contains all that information. And then we supply that to the users on your operations, your IT side, which is handling all the servers, and then, of course, management, which is making sure that the facility is being utilized. So everything you see on this slide here is the integration services that I manage inside of a data center. So if we go back to the EPMS side of it, so up at the top you have your redundant utilities, A and B. We also have redundant generators that supply power in case the utilities go out. You have a paralleling switch gear so that we can one-side it to A and B. Then you have your mechanical with the cooling load, so all the electrical power supplying to the VFDs and things like that. Then you have your UPSs, and the UPSs are supplying just for the critical load to the server. So if you lose power because the utility goes out, it's okay for one of the air conditioners to go out for a second, but if we lose power for a second to one of the servers, all the servers go down. So the UPSs are used just enough, they stay on a few seconds. They have enough batteries to keep it alive for a few seconds, just long enough for the generators to kick in and for the paralleling gear to handle it, to switch it to the load for that. As far as our opportunity, so Infinity Insurance, they're in Birmingham, Alabama. They decided to build a new, well, they actually refurbished a office in downtown Birmingham, and they brought their office space and their data center into one building. So that was the project they are working on. The total size is 1.25 megawatts. They have redundant power, 2 generators, UPSs. They're currently putting in 36 racks, and then they have room for expansion to bring in another 36, so double that space. If we look at the type of devices we're talking to, we have some Caterpillar generators. These were serial, so we had to put some Modbus Ethernet gateways in there to convert it to Ethernet. Also, all the generators come with these huge tanks that hold diesel fuel. There's low level and a high level limit switch inside there to tell you that, but there's nothing that tells you how many gallons are in your tank. So we always have to go in and supply a fuel gauge to basically calculate how many gallons are in there so that they know when they need the truck to show up to fill those tanks up again. Those we bring into a PLC, so we bring analog values and other digital values into there. You have your switch gear, that again is serial, so we convert that to Ethernet. Liebert are the UPS modules. Those were already Ethernet out of the box. And then your output distribution, so from the UPS, there's switch gear to switch in and out the batteries. Those were just dry contacts. Again, we had to supply a PLC to bring in digital I/O so we can monitor the positions of the breaker positions. Whoops, went too far there. Wrong button. Okay, then they had Liebert power distribution units, and that's feeding the power into the racks. And then at the rack level, there's 144 power strips inside there. There's 4 in each cabinet. I think there was 24, or I forget how many outlets are on that strip that are in there. But roughly altogether, there's about 5,000 points of real-time data that we were collecting in the system. So for our network architecture, these EPMS cabinets, those are the ones that we provide. So these are wall-mounted cabinets that you put on, you put in the facility, and depending on if you have Ethernet or serial, you can locate them properly around the place. We always put a switch in there. If they have a fiber loop, we'll put fiber modules in there too. And then if we have to convert from serial, we put media converters from serial to Ethernet. And then if we need a PLC, we have one of those that we can stick in there too. So each one of those boxes are made custom. They're just a 12U high rack that we put on the walls. And depending on what we're bringing in, that decides what goes into those. So that information was brought up to the server. When we collected it there, we actually stored it. We have a separate SQL server where we actually stored all the historical data in there, and then we provided this information out to the clients. So for gathering the data, we use the SCADA integrator. We had 2 protocols, the SNMP and the Modbus. Now, ETAP already has an OPC interface. They also have a Modbus interface. I didn't talk much about the timing of this whole thing. We got an order in November, and they wanted it commissioned and the keys turned over to them March 1st. So, they had all that time building this thing, ripping the building apart, but it's on a checklist for these general contractors as to when you bring in these specific systems. So it wasn't until about 3 months before it's due that they actually, send out the order to get this thing rolling, and they don't give us a lot of time to get these put into place. The reason I bring that up is the Modbus interface. We started using the ETAP interface, but the one thing about Modbus, and I always say this thing, it's the Modbus standard. The great thing about standards is there's so many to choose from. So when these vendors are making their interfaces or their devices to talk Modbus, none of them make them the same way. So if you're making an interface that has to read from Modbus, you have to be very creative in doing that. There's a lot of switches to turn on and off, to swap bits, to read all the different, the string lengths of how much you can send to the device and how much it can send back. All of that is very reliable, or relies on what the vendor did when they built those protocols. So we started off putting this in. The one thing I also didn't bring up is, when you look at how they commission or you start up a system, you start at the substation, you get down to the paralleling gear, you get the mechanical gear up and running as quick as possible because you're trying to balance the facility. And then, by the way, you have these racks that you want to get running. Okay, we'll turn those on last. But for the first time we're ever to touch anything is after they get power to it. So as soon as they turn power on the device, that's when we can go in and do all the configuration that you need, setting up IP addresses or node IDs, and then also checking out that the communication cable that they ran was properly run, not run too close to high voltage, all the things that bring in noise. So as soon as the power's turned on, that's our time to get going here. So when we got to these devices, like checking out the generators, they don't check the generators out till the very end once they get load put on them. We started realizing we were having some issues, like the temperatures inside of the generators they were formatted to give it to us in Kelvin, so we had to convert those. So there was a lot of things that we had to do with the Ethernet Modbus interface, and because of our time limit, we decided to switch to Kepware just because we've used it so many times over the last 10 years. It was just easier for us to get it up and running. And then we used one interface, the OPC server, to bring in SNMP and Modbus into it. Once we got all the data coming in to the SCADA integrator, then it goes into your objects, your equipment objects, and then that fed into the ETAP model. So that was pretty smooth once we got rolling there. The one thing that we also had to change is the nice thing about the interfaces that ETAP does, it does it by a device or a template, which is great when you're talking to different switches and breakers. Well, once we switched everything to Modbus, now everything looked like a single device. Instead of having templates with different registers, we had one huge register mapping, so we couldn't utilize the templates anymore. We had to break them out. So it actually caused us some extra engineering at the end to break out from going to template back to, breaking out how we did the one full list of all addresses out of the OPC server. As the HMI Viewer, in the data center control room, we put down a drill down navigation. So we imported a CAD drawing into the system, and then we had the buttons that do the drill down. Just like you'd see in a typical control room here. So we had down to the gear and then also down to the assets. So we utilized that. The one drawing I don't have up here is we also utilized the ETAP model. So the one line they also have that inside the control room for use. For the web part, so besides the people inside the control room, we didn't want to give the other users the same interface. So these people care more about KPIs, how is our place running. So we built more of a KPI or dashboard type displays. And then we did, sometimes recreate some of the switch gear depending on who the users were. But the goal was not to make the same interface on both the thick client and the web. Trending. Whenever you go into these data centers, every real-time point, they want trendable. So during our commissioning, during everything, any point that we're bringing in, they want to be able to ad hoc and bring up a trend. This is something a little different than what the typical ETAP modeling is used for. The more I see this stuff, I know they don't need to trend all these things, but it's in the requirement that it all has to be trended. So in order for that to be checked off the list, we have to provide that. So there was a little extra effort on our part. We also had to work with the ETAP developers, which were very helpful through the whole process to be able to add in these additional points, because when you drop in a device, it knows these are the most important parameters or attributes that you should be trending, not these. And we're saying, well, we want those too. So, we worked with them and got that all in there, and we're pretty much trending all 4,000, 5,000 tags there. There's probably a few that we were able to get out of the loop. Alarm and events. So, the ETAP alarming inside the control room, that's the area where they can acknowledge the alarms. So the operators are doing that. And then for the other users, we also give them access on the real-time, the WebRT, for a view-only access of what alarms are going on. So we're using both of those. Email notifications, we're also utilizing that. So depending on the users from the distribution list, certain ones get certain alarms for the mechanical and areas like that. Other ones are on different distribution lists. So we were able to break that out according to who's in charge of what. Okay, so our lessons learned. This was our first one. So I was with Frank in the back. We went on this trip and for this sales call. And this was our first sales call actually going jointly together at this. And we knew we had a good story with how this works to be able to use a model and able to compare real time against that. And as you fill your data center, is your data center performing the way it should be? And that's something none of them do. None of them look at. And even asking all the data centers we've done, none of them even have the model or of what it was. So going into this first sales call, we go into the room. Frank's actually showing the ETAP part of the program and how we can bring this model in. And then the question comes up by the customer, to the A&E firm, can we get the model? And so right there, it was like silence for me, and I was just waiting for this A&E firm to say yes, but I was assuming they were going to say no since nobody else had one, and that was going to kill this whole deal. But they came out and they said, yeah, we can get it to them, not a problem. So we left that meeting. I actually got a call from the general contractor as I was driving to the airport, which is like a 20-minute drive, where the customer pulled the GC aside and said, is this stuff real? And he said, yeah, it's real. It does exactly what it shows. And then he asked me on the phone, Brian, is this stuff real? And I said, yeah. I go, it really is. And we went right into negotiating the contract. So they picked us right after that meeting. So it was one of the fastest sells I've ever had, which shows the power of this whole thing. But when we got to the point where everything was signed and we signed the non-disclosure with the A&E firm and they sent us their model, we imported it. It imported right away, and we're all excited. We got to work right away. I sent 2 guys to the local office here to be trained on it, and they were doing all the stuff. But it wasn't until they got towards the end, where we're at the PDU level and all that we realized the model they sent us didn't model any of that. So at that point, we didn't go back to the A&E firm to figure out what, if they had a newer model than what they gave us. We just did it all ourselves. But we didn't know what we didn't know. So that was our first time doing it. Now we know a little better, so we take a better look at that model. Also asked the A&E firm, hey, is this your final? Because I didn't even ask that question when they sent it to us. So, so that was one of the lessons we learned there. Roles in security, there's nothing new here, but it was pretty late in the game when they were, getting the IT people's attention to come to us and, be able to sit with us to tell us, how their network, their internal network's set up, how the domain's set up. We're on a private LAN over there. Are we going to have access to the domain? All those questions they hadn't even figured out yet. And we were like into January, late January, before they even gave us that information. So the whole configuring that and setting up the security and the roles, we didn't get that information until very late in the game. The issues with the ETAP Modbus driver, I talked about those. We are working with the developers. Actually, while we were on site, while we had things commissioned, I told them to reset up the ETAP driver just to make sure we could talk to certain things so that if there was a bug in the software, we could figure it out. They were able to get it working and get it talking, so we just need more experience with working with that particular driver, to see what's happening with that. But that's something we're working on together. And then the graphics, when we're putting these together, especially if you look at the breaker level, we'll have hundreds, sometimes thousands of breakers. Some of our data centers we work at, are 20 megawatts. So it's almost like a little city or something, that we're bringing in. So the amount of breakers that we're putting in, and we like to do everything with templates so that we only have to change one screen and roll it out. Now this is something that's working on and it's coming, but at this point, and especially with the way we broke it by bringing everything into OPC, we weren't helping ourselves, with templatizing there. And then between the viewer and the graphics, there were certain graphics, again, we didn't want them to be the same, so it wasn't, that big of a deal, but, being able to import or export from one of those to help you set up or start configuring the other one, that was something that wasn't in the product. So those are things that, it took us a little longer to develop the graphics because we couldn't share between the two. And then again, we had 4,000 points we had to bring into the trend thing. So there, now that we know how to do it, we could get that all done up front. But we ended up not realizing what we had to do to bring these trends in, and we did a lot of that work, while we were on site. Now that we know about it, it's no problem. It's an easy way of setting up some Excel spreadsheets and importing. But when you have commissioning people breathing down your back, it gets a little heated. So going into the future here, scaling, bringing in this amount of data. And so, right now that was about 5,000 tags. We easily see 50 to 100,000 tags. I have a customer now that's at 1 million tags. So, it does scale pretty high. Being able to store that information. That one customer that's 1 million, they want to have 3 years of online data. So the whole way of historizing that data, being able to bring it up quickly, that's an issue. That's something, we've been discussing how we're going to handle bigger clients. And, just getting into this, I was saying I was using 5% of what ETAP can do. I think I'm down to 2. I think we're utilizing probably 2% of what this product can do. So there's a lot for us to learn. There's a lot more that we can provide to the customer. We're actually setting up future meetings. They actually just got the keys in March. They're still putting the servers in, so I don't even have any real-time trends showing, how their loads are and how balanced things are. They're not even to that point yet. So a year from now, we'll probably have better exposure to how that's all going. So we're working on that. And then the marketing of this, marketing this to be used inside of a data center, we're working on that too, because we do see the benefits of getting it in there and using this product in that way. And then, working with the developers on how we use it inside of a data center. So the modeling, the way they do it, but the way we use it inside of a data center is a little different. The way the control people want to use it, the people in the data center, control room want to see it. They're used to certain ways of doing things, even though we don't totally agree with what they are, but that's just the way they've been trained and how it's always been done. But we're trying to bring them up, into the future, make them see things a little differently. And that's it. So thank you.